Rutherford's model of the atom is much closer to our modern picture than the plum pudding model, but the nucleus was still imagined as just a blob of positive charge. Rutherford was principally interested in radiation, and he thought that understanding more about the nucleus might help. An obvious question was, is the nucleus itself made of smaller parts? Another of Rutherford's collaborators, called Frederick Soddy, was doing experiments sending alpha particles through different gases. He found that particles just like the nucleus of hydrogen atoms were sometimes produced. Perhaps all nucleuses were made up of different numbers of hydrogen nucleuses. Rutherford named the hydrogen nucleus a proton, which is the ancient Greek word for first. The Dutch physicist Antonius van den Broek had suggested that an element was defined by the electric charge of its nucleus. It's only a short step from this to defining an element by the number of protons that makes up its nucleus, which is what we learned about in lesson 1. The problem was that protons couldn't account for the measured mass of a nucleus. The measured mass was always about twice as big as it should be. Soddy also realised that different nucleuses of the same element could have different masses. We came across this concept of isotopes in lesson 1 as well. Maybe the two observations were related. It seemed likely that there were sort of neutral protons or neutrons accounting for the rest of a nucleus's mass. The problem was that it would be very difficult to detect neutrons because they have no electric charge and so would tend to go straight through any measuring apparatus. In 1932, the French chemist Irène Joliot-Curie, the daughter of Marie Curie, of whom more later, was working with her husband Frédéric in Paris. They knew that when alpha particles were made to strike a thin sheet of beryllium, there seemed to be some kind of ray that produced protons when it in turn hit paraffin wax, but they didn't know what the ray was. Another of Rutherford's colleagues, James Chadwick, was convinced that these rays were in fact a stream of neutrons. He imagined an alpha particle knocking out a neutron from the beryllium nucleus, which in turn knocked out a proton from the paraffin wax. By repeating the experiment in lots of different ways and measuring how fast the protons moved, Chadwick could calculate the mass of a neutron. It turned out to be very slightly higher than the mass of a proton. So that's it. We now have our modern view of an atomic nucleus, made from roughly equal numbers of positive protons and neutral neutrons.